In this video, we will discuss the basics of reaction mechanisms. Reaction mechanisms are a series of steps that lead to an overall reaction. What a lot of people don't understand is that most reactions that occur in several steps. And from those steps, we'll get the overall reaction. So for example, I've got a reaction here. A plus 2B's gives me C, or gives me E plus F. And it turns out that this hypothetical reaction actually occurs in 3 steps. And those 3 steps give me the overall reaction. So A and B combine and give me C. And then C reacts with another molecule of B to give me D, and then D breaks apart to give me E and F. That's what this hypothetical reaction is telling me. And so for a brief moment in time, I do have C, but C is ultimately consumed. And if I looked at the overall reaction, I would never know that there was, in fact, a C. And then the same thing is true for D. D is produced and then later consumed, and that is a definition of a intermediate, and it's something that's produced and then later consumed during a reaction. Now let me add in here, let's say there was X, element X that we started with, and then at the very end, X was spit back out. And so what we could say is that X, we started with it and we ended with it. And that would make X a catalyst. And chances are X being a catalyst, that would behave in a way that it would lower the activation energy, effectively increasing how fast the reaction can occur because there's less energy that has to be overcome. And with all of these steps, it's typical that one of them will be just a little bit or even a lot slower. And so for example, we could say that this first step here is the slowest one, where the other 2 we could say are fast. And so it doesn't matter how fast steps 2 and 3 happen. It all depends on that first step. It's sort of like if you work at a pizza restaurant, when you make a pizza, oftentimes the slow step will be getting the sauce on the pizza. You can't put toppings on your pizza until the sauce is there, and if you have someone that's very slow at putting sauce on the pizza, then that's going to be what impacts how fast pizzas can be made. And the same thing is true here for this reaction. And so in AP Chemistry, what we typically see are little tables like this, where they say, okay, we have this mechanism, and this is step 1, whether they say it or not, and then this is step, oh goodness, that's bad spelling. This is step 2. And so the first thing we want to do, and these problems kind of lead us through here, is we want to know the overall reaction. So I know I start out with NO2 and F2, and then I produce NO2F and just F. And it turns out that F is reacting in the next step. So F is what we call an intermediate, and it looks like we then add in another NO2, and we end up producing 2 NO2Fs. And so we can say 2 NO2s plus F2 gives me NO2F, and I have 2 of those, and if we checked it, we would in fact see that it does balance out. So when I look here, they tell me that the first step is slow. That means this overall reaction can only occur as fast as that first step, meaning that the kinetics, or the rate of this reaction, is just based on that slow step, that step 1. So we could say rate is equal to K. And in that first step, we know exactly how many things we need. In a normal reaction, like this one, where we're given the overall reaction, we cannot figure out the steps unless we have it broken down. And so I don't know what the rate depends on if I'm just given this. However, we have the slow step and its the specifics of it, so we know what is involved. We need 1 NO2 and we need 1 F2 for that slow step. Okay, and so that's the rate law for this reaction. If we look at this next one, the overall reaction, they give it to us this time. We just need to find the rate law, and so I'm going to find the slow step, and so that's going to be rate is equal to K. We only need 1 A, and then we need 1 diatomic B, and so we get this as our overall rate law. Let's just see, though, what would happen if A was actually 2 of them. Then this 1 would just change to a 2, and it's still the slow step. Okay, let's look at this next one. We're given this overall reaction, and it looks like it's one of those reactions that just balances itself. And we are given that this is step 1, and this is step 2. We're given the overall rate. And so what we want to see is what's the rate determining step, aka what is the slow step. And what I want to do is I want to compare step 1 and step 2 and see which one would actually give me this rate law, if either of them would. Okay, and if I did the slow step, if I called step 1 the slow step, that would be rate is equal to K NO2 NO2. And yeah, that actually looks okay because I could simplify this and say rate is equal to K NO2 squared. And so I think that's right. Let me just double check that if step 2, if I wrote the rate law, if that one happened to be the slow step, I'd say rate is equal to K NO3 to the first power CO to the first power, and that does not match that at all. So it's got to be step 1. That must be our rate determining step or our slow step. Okay, I'm going to jump forward to some harder questions, and these are the questions that if an AP chemistry student is going to goof up on, it will be this one. And so it says we're given step 1, step 2, and step 3, and we need the overall balance equation. That's always a good starting point. So N2O2 is a intermediate, N2O is an intermediate, and I think that looks pretty good. So we have 2 NOs plus 2 H2s, and that gives us just a nitrogen molecule plus 2 waters. Okay. Identify the intermediates. We've done that into O2 and into O. And then what we want to do, and this is the part that people goof up on, and this is difficult, so I can understand why, but we got to make sure we understand how to do this. We want the rate law for the reaction. Well, we've talked about that the rate law is going to be based on that rate determining step, which is the slow step. So I'm going to go ahead and write that. Rate is equal to K into O2 to the first power, and then H2 to the first power. And you might say that we're done. However, this cannot be the rate law. This cannot be the rate law because there is an intermediate. And that's just not going to work, because if I give this to a chemist and I say, okay, I found the rate law and the rate of this reaction is based on N2O2 and H2, they're not wrong. However, N2O2 is an intermediate, and so there's no way to manipulate the reaction if we say N2O2, because we never started with it. We can't control the molarity that we begin with of N2O2. So here's what we're going to do. We're just going to substitute, and I'm going to go back to the previous step. So I'm going to go back to previous step, And I'm going to say, okay, into O2 to the first power, that's in the previous step, is equal to NO squared. That's just here from the previous step. So all I need to do is I just need to substitute, and I'll take this, and I will just do that substitution, and I will erase the into O2, and I'll change it to NO squared. Now, this is my rate law, and I have two reactants, NO and NO, and then H2 and H2, so I can control the rate of the reaction with those two. Okay, let's do one more example, and then we'll call it quits on this. In part I, it says, is CH3Cl a catalyst, an intermediate, or is it just a catalyst or intermediate? So we need to justify our answer. So let's find that guy first. And there it is. And it looks like I produce it and then consume it. So CH3Cl is produced and later consumed. Thus, that makes it is a intermediate, or I should say an intermediate. Okay, excellent. Now, determine the order of the reaction with respect to CH4 and Cl2. So this is basically when I see this. And by the way, the overall reaction, I've already done that. The overall reaction is CH4 plus Cl2 goes to 2HCl plus CH2Cl2. And what I need to do is I need to find my slow step. This is just asking me for the rate law. So it's going to be rate is equal to K. Here's my slow step. Cl to the first power, and then CH4 to the first power. And that will not work because Cl is not in my overall reaction, and I can't have an intermediate in a rate law. So what I need to do is look at the previous step. And I need to say, okay, if I look at the previous step, what do I have going on? I have Cl squared, or is equal to just Cl2. And what I need to do is I need to just substitute Cl. Well, these two right now that I have highlighted are not the same exactly. I need to make them exactly the same for substitution to work. So what I'll do is I'll take the square root of each side, and I'll get Cl to the first is equal to Cl2 square root. And if you remember from algebra, that's just to the 1/2. And now I have an even substitution. So I will take this and I will substitute it. And I can actually do that without erasing too much. And there we go. That's the final answer.